Assalamualaikum warahmatullahi wabarakatuh and good day everybody. My name is Muhammad Zamri bin Mawiso. I'm the final year project coordinator for Metro Panels. Today I will give a briefing on the metro characterization techniques and guide for the final year project students. I hope that this video will help the final year project students to understand and present the analysis data properly during the final year project presentation. Okay, this is the overview for this presentation. Okay, we start with the approach for metric characterization, and then I will explain about the pretreatment or condition of sample for each analysis. And finally, I will share some example data to understand how to present the data that you already obtained from the metric characterization. Okay, there are a variety of materials and chemical analysis that we can use to study our sample. Okay, each analysis is divided into different categories, such as surface information, subsurface information, atomic scale information, and so on. So each analysis also will provide different information, and we can use this information to support each data. Okay, for example, okay, ICM data can be backed by TM or EDX data, or Raman data can be backed by the XRD data. Okay, so a concrete statement about metric characterization should be supported by more than one metric analysis results. There are a few popular metric characterization that is viable in UTM, and I can divide this analysis into two big groups. Okay, so group number one is compositional and phase identification, and group number two is morphology and structure identification. Okay, so each group has a specific instrument. Okay, so for example, for compositional and phase identification, we have XRD, FTIR, and EDX. For the morphology and structure identification, we have SEM, OM, which is optical microscope, TEM, okay, for transmission electron microscope. Another one we have also AFM. FM more likely to study the roughness of the sample. Okay, so each material characterization, okay, will give different results. Okay, for example, for SRD, okay, we can analyze metals, ceramics, semiconductor, or composite materials as our sample, and we can obtain crystallinity or amorphous information, elemental compositional, and particle sizes. Okay, we can obtain from SRD. For the FTIR, most likely we can only use organic or polymeric samples, and from there we will obtain the functional groups data from our sample. Okay, for the EDX, okay, energy diffusive X-ray, okay, the main sample must be conductive. Okay, the main sample must be conductive, and from there actually we can identify the elements in the materials. Okay, for the SEM data, okay, almost similar to the EDX. Okay, the sample must be conductive materials. Okay, so from the SEM data we can obtain surface morphology, which is in micro scale or nanoscale. Okay, if we use FISM, maybe we can obtain up to nanoscale. Okay, for the optical microscope, okay, actually we can use any materials. Okay, and we can obtain grain boundaries, for example, for metals, or structure at macro scale. Okay, for the transmission electron microscope, okay, for this one actually the sample is a bit difficult to prepare because it must be electron transparent materials. What does it mean by electron transparent materials? The sample must be very thin enough to allow electron to pass through the sample, so the thickness must be around 100 nanometer. Okay, and the result actually we can obtain structure in nanoscale and also lattice distance of the crystal and diffraction data of the sample. Okay, so if you want to study about the surface roughness, for example wrinkle and so on, you can use atomic force microscope, which is we call as AFM. Okay, there are some conditions that can improve the analysis results or must be fulfilled to obtain a very good results. Okay, for example, for SRD analysis, uh, we can use powder or bulk samples. Okay, in the case of the bulk samples, okay, the sample must be polished to improve the results. Okay, you can polish the sample at the mattress engineering laboratory in E06. Okay, for the FTIR, which we need to use polymeric or organic sample. Okay, the sample must be in powder form to reduce the scattering losses. So if you use a very big particles, okay, the result won't be not very nice lah. Okay, for the DX analysis, okay, basically the sample must be conductive. You can improve the conductivity by use coating, okay, or if you use powder sample, okay, the powder must be properly dispersed on the flat materials such as silicon plates, alumina, or carbon plates. Okay, so this will improve the results of the IDX results. For the scanning electron microscope, okay, the sample must be conductive, which is similar to the DX. Okay, and for example, if you have a powder sample, the powder sample must be properly dispersed on the flat materials such as silicon plate. Okay, you can disperse the powder using the ultrasonication. Okay, depends on your sample. Okay, normally we only sonicate for around 5 minutes. Okay, for the optical microscope sample, in the case of the bulk sample, okay, the sample must be properly polished with the epoxy cast. Okay, or if you use a powder sample, okay, that sample must be dispersed after the sonification process. Okay, so for optical microscope, it's really quite simple analysis. Okay, for the transmission electron microscope sample, okay, if you use powder sample, the powder must be dispersed after the sonification process on the copper mesh. Or if you use bulk samples, okay, actually you need to cut the sample using mechanical cutting, and then we need to do the thinning process using the ion milling process. So this is a bit complicated process, but if you need further information, you can contact the staff in the PPMU, or you can contact me. Okay, for the atomic force microscope, okay, ideally the sample must be a flat surface lah. So you need to prepare your sample as flat as possible lah. So if your sample is for example too rough, okay, maybe the result won't be very good, because for the AFM, it have a specific tip, and this tip have a limited scanning depth, so depend on the roughness of the sample. Okay, I already explained about the precondition or pre-treatment required, okay, to improve your analysis results for each metric characterization. Okay, so now I will explain how you can present the data. Okay, so we start with the SRD. Okay, so for SRD, basically you need to replot the graph using Excel or Origin software. Do not use the screenshot of the graph that you obtain from the machine. Okay, it's not very good. So why? Because normally when we want to present our results, okay, first we need to show uh, the result of the analysis. For example here, okay, you can see image A here, it show the result of the analysis. And then normally we'll focus on the what we want to discuss specifically about our sample. For example, this one is the SRD pattern of the hot dip galvanized sample. Okay, so they want to discuss about the combination about on iron and zinc phases. Okay, on the coating sample. Okay, so here the insert they focus for this range between 30 to 60 to theta degree. Okay, so here we can discuss properly lah for this range. Which means that when you do the analysis, it's not necessary that you need to do more, how to say, reading on your sample. Actually, for one single reading, okay, actually you can analyze the data properly after you replot the graph lah, on a much more specific range. Okay, the next sample, for example, okay, you want to compare a few different results, okay, using SRD. Okay, so this is one of the example. Okay, you can use the stacking graph to compare the SRD result for each sample. Okay, no need to use a specific intensity, okay, because we can ignore the intensity. What you want to study actually the peak, is it is shifted or not, also depend on how you want to discuss your sample. So this is one example that you can use if you want to compare a different sample using SRD. Next, actually, to support your data, okay, normally from the SRD we can estimate the particle size of your sample. Okay, you can use the Scherer equation. So this is the Scherer equation. Okay, so after you obtain the result from the Scherer equation, actually you can also report the data lah. For example, this one is the sample same results, okay, A and B. Okay, this is result from the peak, and here is the differences of the particle sizes for each sample. Okay, so this is how you can make the data much more interesting and fully analyze your sample properly lah, with the every data you obtain from the SRD results. Okay, next is FTIR. Okay, so for FTIR, not many students use this kind of analysis instrument. Okay, this is because that for FTIR is limited for the organic or polymeric sample. But for the FTIR, actually, it's very interesting analysis instrument. This is because that it can give the functional group information. And this functional group information is almost similar like a fingerprint for your sample. For example, if you have different paint coating, for example, if you study about corrosion, right? Okay, so if you blend two different polymer, okay, then you want to replicate back the original paint, for example. Okay, FTIR actually can become like a fingerprint, which means that you can obtain the actual paint composition, okay, by using the FTIR. Okay, so this example of the functional groups with a very specific data. For example, for wavelength 3500, okay, so normally it show a stretching and it represent by the OH are called functional groups. So each wavelength actually represent a specific functional groups. Okay, so you can obtain this data actually from the reference lah, general reference. Similar to the SRD, okay, for FTIR you need to always replot and using the graph lah. Sorry, you need to replot and the graph using Excel or Origin software. Okay, so from there actually you need to label all the peak, okay, to identify which part you want to discuss during the presentation. Okay, next for the EDX, okay, similar to other graph, okay, you need to always replot the graph using Excel or Origin software. Okay, so there are a few techniques to present the EDX results. Okay, for example, if you only take the EDX result without the SEM image, okay, you can use this kind of technique to present your sample. Okay, however, normally when you do the EDX, you will always using the SEM. Okay, so it is good to combine this data. Okay, for example, okay, this example, okay, So you combine SEM image, okay, and this is the EDX results for this SEM image. So you can combine this data, SEM, with the EDX results. Next is this one, different area with different, slightly different morphology, okay, and this is the data for this EDX data for this area. This is another example. So for example, you have different multiple sample, okay, so you can present using this technique. Or if you have more opportunity to using the mapping, EDX mapping analysis, okay. For example, you have one morphology here, and then you want to do the mapping to study about the morphology properties, okay. So this is the combination of the whole mapping area, okay. This one B, and this is mapping for carbon, this one mapping for oxygen part, and this one is mapping for nitrogen, okay. So basically this one is the graph of the EDX result, huh? So you can combine all this one in one image, huh? Okay, so this is how we can present our results using the by combination of the EDX mapping and also SEM results. Okay, next for the SEM. Okay, I will show how we can combine the EDX with SEM results. But not all sample require EDX analysis. Okay, for example, you have too many samples. Okay, you want to study only using SEM. Okay, so this is one example. For example, this one you have three different sample, and then you analyze at different magnification. Okay, different magnification here, and then you just arrange the result data. Okay, so from here actually we can properly compare that for the magnification at 500, obviously there are almost no significant changes that we can observe, but at the magnification of the 40,000, okay, so here actually we can clearly identify what's the difference between sample 1, 2, and 3. Okay, so this is how we can use different magnification to observe differences for multiple sample. Okay, or we can combine SEM results with the different magnification. For example, this one is only one sample here. Okay, so this one is one sample. Okay, so and then they properly label at the specific area where they want to discuss. Okay, and then by using different magnification, okay, so they provide the insert image and discuss for the different location. So for in this case, for example, they properly label the sample where they want to discuss this part and all this part. So okay, so E actually the higher magnification. So this is the image of E area. Okay, so this is image for the D area here. Okay, so this is how you can use the SEM to properly discuss your results. Okay, next, you can use optical microscope. Okay, so not many students want to use optical microscope. Why? Because for this one, normally they doesn't know how to compare the sample or how to prepare the sample. This is because for optical microscope, okay, you can obtain a very good result if you do the polishing process. Okay, so this is one example. Okay, for example, you have a few different sample. This one, for example, you have 6 different sample. All sample are polished properly. Okay, right. And here, when you want to discuss with a different sample, make sure you will label with okay the area you want to discuss lah. For example, here with the 6 sample, right? Okay, so here with 6 sample with a proper label, the discussion will be much more interesting and more specific part, which condition you want to discuss. Okay, or for example, you only have one sample but you have different condition. Okay, for example, when you do the testing, okay, uh, you want to study about the fracture surface of the sample at the very at the specific for this one, sorry, this one not fracture, this one is a cycle, right? So this one is fatigue result fatigue fracture lah, of the results. Okay, so this one is the optical microscope. So with the different cycle, okay, they study about the fracture area. So this one how they present the data. So very interesting, even though by using only optical microscope. Okay, next is TM. So this is the most likely a student, final year project student will use lah for the analysis. This is because that for the TM, okay, the sample preparation is very, very difficult. Okay, if your sample is powder type of sample, then quite easy lah to do the analysis of the TM. Okay, so this is one example. For example, okay, you have, for example, three different results, A, B, and C, right? So normally we need to take the low magnification here. So this is A, is low magnification, similar to this one, A. And for the bottom image here is D, E, and F is the high magnification results. So you can see from the different of the scale. So this one is 5 nanometer, right? So this one is 0.2 micron. So the scale is totally different. So this is low magnification, this one is high magnification. So at the high magnification, if you have a very good sample, okay, normally you can easily observe the lattice distance. Okay, so if you involve with the alloy or ceramics kind of sample, so it should be very easy lah, to observe that lattice distance. So and then obviously to confirm about the lattice distance, normally we will do the diffraction. Okay, so this diffraction actually represent for this area. Okay, so do not mix different diffraction area with the different image. Normally you should take the image first, and then later you need to take the diffraction for this area, and then later actually you can calculate lah the diffraction. Okay, so this is how you present lah the sample data. If you can present like this, properly label, okay, label the lattice distance, okay, and then provide the diffraction data. If you can calculate the diffraction, it will be much more interesting. Okay, so this is how we can present the TM data. Another example is, for example, you have only one sample, but you want to combine the result of the SCM, okay, with the TM. Okay, so in this case, this is only one sample with this structure, almost like rambutan, right? Okay, so this is low magnification of image of the SEM. This one is slightly higher magnification SEM image, and this is the low magnification image of TM. Okay, you can see the structure, and this is moderate magnification of TM. Basically, the sample, what we can see here is I can assume as a amorphous sample. Okay, so this is how you can present this, the sample. So by combination of SCM and TM, okay, the data will be much more interesting to discuss. Okay, next, how you can present the FM data. Okay, so basically for the FM data, normally we want to discuss about the surface roughness, about the wrinkle, about the morphology structure of the sample. However, the surface roughness must be with a specific range lah. It cannot be, I think, more than 5 micron. If the surface roughness is more than 5 micron, actually we cannot identify using the FEM, because the tip have a limited depth and screening. Okay, so you need to have a specific sample. So this is how, for example, you have two different sample here. So this is two different sample. Okay, so this is the 3D image, this is the topology. Okay, so this is how you can compare about the result. And normally at the bottom of the result, okay, we will present the surface roughness lah. So this is the profiler, surface profiler, and this is the we can call as the average of the roughness. Okay, so this is for single sample. Okay, so this one is for the multiple sample. Okay, so for multiple sample, normally we're not using the 3D image, we're only using the topology. So from the topology, actually, normally you can compare using the you can label which part show the significant roughness that you want to discuss in your research. Okay, so and later on the combination of the roughness, okay, you can replot here like at the bottom. So normally if you can replot like this, okay, the data will be much more interesting. Okay, so that's all about the metric categorization technique and guide for the final year project student. I hope that you can have some insight about how you can present your data and what you should do. For example, the pre-treatment or condition that you should prepare for your sample to obtain a good results. Okay, so that's all for today. Thank you.